All right, and we're going to continue our conversation about parallel lines today. And in the last lesson, we worked on determining if lines are parallel. And so what we want to do today, all right, is write equations of parallel lines. We might start with one line and then try to create a second line that is parallel to that line. So you can see that standard 6.2 here, all right, in our Unit 3, Lesson 3. And so what I'm going to have you do right now is the opener. All right, so after I read this, I want you to pause the video, all right, do the opener, flip it back on, and we'll see how you did. So if line 1 goes through the points 5, 4, and negative 2, 10, and line 2 is represented by the equation y equals negative 6 sevenths times the quantity x minus 7 plus 3, are these two lines parallel? All right, so I want you to pause the video, flip it back on, and we'll see how you did. All right, so let's take a look at the work here. So here's what I did first. All right, so we know the slope in the second line is negative 6 over 7. And we know that if two lines are parallel, all right, we want, all right, to have the same slopes. So the first thing I did was I took my 2 points that line 1 goes through, 5, 4, and negative 2, 10, and I found my slope. So negative 6 over 7. So now I can see that they have the same slope. So now what I need to do is verify that they have different y-intercepts, so we're not talking about the same line. So I wrote the equation of my first line. So I took my slope of negative 6 over 7. I took my point 5, 4, and I wrote my equation in point slope form. Now remember to go from point slope form to slope intercept form so we can compare those y-intercepts. We need to distribute and then combine like terms. So the first thing I did was distribute my negative 6 over 7 to the two things in my parentheses here. All right, that gave me this line. Then I added my like terms, and I got 58 over 7. Now most of you probably did this on your calculator, and so you have a decimal answer. So you have 8.28. Either way is fine. What we just want to do is get to slope intercept form so we can compare y-intercepts. Now, what I did now is take my second equation, line 2 here, which is already in point slope form, and I just need to convert that to slope intercept form. So once again, distribute your slope, all right, to the two items in your parentheses, combine like terms, and I got 53 over 7, or if you got a decimal, 7.57. So what I can see here is that I have two lines with the same slope, but different y-intercepts. So the answer is yes, they are parallel, right? And I'm going to use the parallel symbol right there. All right, so two lines kind of slanted. All right, that's our parallel symbol. All right, so they are parallel, and the reason is they have the same slope, different y-intercepts. All right, so hopefully, all right, you understand that. That's a quick review, really, of a lot of the items that we talked about in the previous lesson. All right, so now let's talk about creating or writing equations of parallel lines. So what we need to remember is that the easiest way to write an equation of a line is point slope form. And that form is this. Y equals m times the quantity x minus x1 plus y1. All right, and that parallel lines have the same slope and different y-intercepts, which is what you just did in the opener. Now, the good news about what we're doing today, all right, is that we're going to assume, right, that that second line will have a different y-intercept from the given information. All right, so we just need to write that equation in point slope form, and then we are finished. All right, and you'll see what I mean by that as we go through some of the problems. All right, so let's look at problem 2. All right, so we want to write an equation of line that is parallel to this line, y equals 3/5 x minus 3, that passes through the point negative 4, 2. Now, here's what I mean by making that assumption. We're going to assume, all right, that this information is going to create a second line and not the same line. All right, so we know it passes through the point negative 4, 2. So that's our point that goes into our equation. So right now, all right, and it's going to be x minus negative 4, so it becomes x plus 4. And then we have the plus 2 out here. So we know what point it has to go through. So that is done. Now we have to think, okay, if I want my lines to be parallel, we go back to this piece of information right here. We need them to have the same slope. So I have to identify the slope in this line and then plug it in. And we can see that the slope in this line is 3 over 5. I take that and I just plug it in like that. And there's the equation of my line that is parallel to my first line and goes through the given point here. And that's it. And that's all the work we need to do for this particular problem. All right, now let's look at number 3. All right, you're going to see that there's going to be a little bit more work involved in this one. All right, and I'll get to that in just a moment. So once again, we're going to write the equation of a line that's parallel to 6x minus 7y equals 14 and passes through the point 1, negative 5. Now, once again, we already know it goes through 1, negative 5, so we know it has to be x minus 1 in our parentheses there, and then we have the minus 5 out here. So once again, if we want our lines to be parallel, we need the same slope. And here's where that little bit more work comes in for this particular problem, because notice I don't see the exact slope when I'm in standard form of a line. So I want to do a little bit of manipulation to that equation so that I can see its, to get it into slope-intercept form so I can see its slope. So the first thing we want to do is subtract 6x from both sides. So negative 7y equals negative 6x plus 14. And then I'm going to divide by negative 7. And remember, you have to divide everything in that equation by negative 7. So that leaves me y, because that's 1. And then negative divided by negative is a positive 6/7 x. And then 14 divided by negative 7 is negative 2. And so this is that little bit of work, right? So now once I've done this work, I can see the slope of my first line. My given line is 6/7. I want that slope to match. So it's got to be 6/7 here. All right, let me make that a 7 that you can see. There you go. And that's the work that you have to do. All right, so let's look at number 4. Let's look at number 4. Write an equation of a line that's parallel to y equals 9 and passes through the point 3, negative 7. Now, this is once again one of those special situations. You have to visualize what y equals 9 looks like. All right, and so if I think about my coordinate grid, y equals 9 is a horizontal line, all right, that goes through 9. Now, to be parallel, if I start with a horizontal line, I need another horizontal line. So if I think about the point 3, negative 7, so 3, negative 7 would be somewhere over here, I need another horizontal line. So I need a horizontal line that goes through 3, negative 7, like that. All right, so this is y equals 9. And then to have my parallel line, I need another horizontal line, which means I need another y equals. And then I look at my point. Okay, so what does y equal in this point? It equals negative 7. And so there's my equation. So when we're in our special circumstances, if we start with a horizontal line, we need another horizontal line to be parallel. If we start with a vertical line, we need a second vertical line to be parallel. All right, so that's one of those cases where you have to look at what kind of line you have and then use that to help you in writing your equation. All right, let's flip to the back here. All right, and now, once again, write the equation of a line that is parallel to x equals negative 2 and passes through the point negative 5, negative 1. So once again, right, x equals negative 2 is a vertical line. So I need a second vertical line in order to be parallel. And negative 5, negative 1 would be over here somewhere. So I need a vertical line that goes through that. Well, now I have to look at my point. So what does x equal in this point? X equals negative 5. Okay, so that's what you have to think about with, and we're dealing with horizontal and vertical lines. All right, now look at 6. So once again, what's changing is not the end result. We always want the same end result. What's changing is how the information is given to us in the problem. So notice we still want to write the equation of a line that's parallel, but instead of giving us an equation, it gives us the points that some points that the line goes through, and we still have the same thing here. It passes through the point 0, 7. Well, once again, I know what point it passes through, so I can do that, right? So what I need, once again, is slope. And so what's changing is how do I find slope? If I have an equation, I can look for it, or I manipulate the equation to get it. If I have 2 points, we just want to make an XY table real quick. So 2, 4, negative 3, 1, and we want to just find our slope this way. All right, so 4 to 1, I go down 3. 2 to negative 3, I go down 5. And we know slope is rise over run, change in y to change in x. So negative 3 over negative 5, which gives me a positive 3/5. So there's my slope. And so I want it to be parallel, so I want the exact same slope, and there's my equation. Now, because it's x minus 0 here, you can simplify this and just write this as y equals 3/5 x plus 7. All right, so it simplifies down to that pretty quick. All right, so let's look at 7 here. So once again, write the equation of a line that's parallel to the line that goes through negative 3, 6 and 1, 6 and passes through the point 4, negative 2. So I know it goes through 4, negative 2, so x minus 4 minus 2. And then once again, I have to go through that slope process. All right, so let's do our xy table here, negative 3, 6 and 1, 6. Now notice what happens here. Our change in y is 0. All right, our change in x is 4. So my slope is 0 over 4, which is 0. And so I've got to think about what kind of line that is. All right, so what kind of line has a slope of 0? All right, so that means that there's no run, or excuse me, there's no rise, there's only run. So that means that we are horizontal. And once again, if it's a horizontal line, we know that's y equals a number. notice in this case, if I plug the 0 in here, 0 times, all right, all of this is 0. So that just leaves me with y equals -2. So there's the equation of my horizontal line. Now, if I go back and look, there's -2 in my point, right? Y equals -2. Now, look at these points. And can you see how the y's match? Well, if the y's match, that means the equation was y equals 6. And that's your equation. And so we get really, this is the same example that we just looked at in number 4, but just given to us in different information, right? So we had a horizontal line to start. So a parallel line, we need another horizontal line. All right. So if your coordinates match, that's a really big hint to what the equation was. So if the y's match, that means you have a horizontal line, and the equation is going to be y, what equals that number. Now, let's jump down to number 8 and see how that translates. So notice now, write the equation line that's parallel to the line that goes through 5, 6, and 5, 1. So notice something here. The x's match here, and they match in the same way the y's match here. And so when I look at this, this is a pretty big hint that my equation should be x equals 5. Now, if you didn't see that and you went through your slope process, notice what happens here. You get 5, 6, you get 5, 1. Notice I have a rise of -5, but this time I don't have any run. All right, so my slope is -5 over 0. Now remember, you can't divide by 0. All right, this is an undefined slope. And you have to understand, like, what kind of line has an undefined slope? It is a vertical line. There's no run. We're only going up and down. So that means we started with a vertical line. And we can see that in the matching x's here. So then, just like we did above, right, if my vertical line is x equals 5, I need another vertical line. And so I look at this. Well, what does it go through? All right, x goes through 8. All right, when we think about that. And the thing is, you can't simplify with an undefined slope. It doesn't multiply to simplify like 0 does. So you have to understand that if I get undefined slope, what that means. All right, almost there. Okay, let's look at a couple more examples here, but let's look at it as a graphical, all right, interpretation. And I know my lines are a little faint here, so I apologize for that. But we're doing the same thing, right? So we have our given line, but it's given to us graphically. We're given a point, and we want to write the equation of our new line. And we're just having you like think about this by, all right, plotting a second point and drawing that new line. So if I think about this, my equation has to go through A. My new line has to go through A, and that coordinate is -5, 3. All right, so y equals, and then x minus -5 becomes a plus, and then I get the +3 here. So once again, I need the same slope. So if I count my slope here, I go up 1, 2, 3, 4. So I go up 4, and I go over 1, 2, 3, 4, 5. So my slope is 4 over 5. So my new line should have a slope of 4 over 5. So up 1, 2, 3, 4, right? And then over 1, 2, 3, 4, 5. And I can draw my new line just like that. And you can see that they definitely look parallel, right? And I constructed them to be that way. So +4, +5, we can call this point B. All right, so I know my slope has to be 4/5. And when we say by naming the line, is that if we construct 2 points, we know from unit 1, right, that we can just call that line AB. All right, and we put the little line symbol over the top. And that's what we have. Let's do one more together. Let's do number 10 here. All right, so once again, here's our given line. And we want to write and draw an equation line that's parallel to our given line here that goes through point A. Well, this time point A is 4, -2. So y equals, and then it would be x minus 4 minus 2. And so I need to construct my new slope. And once again, I go 1, 2, 3, 4. And notice I'm going down 4, so that means my slope is negative. And I go over 1. Can't read that, +1 like that. All right, so my slope is -4 over 1. Now, notice here, I go down 1, 2, 3, and I go off my grid. So what I want to do is reverse my slope. So I'm going to go up 1, 2, 3, 4, and then to the left 1 to create my new parallel line. So just remember, you can reverse your slope, all right, to create that line. We'll call that C. So we'll call this new line AC. We know the slope has to be -4 over 1, or just -4. And there's my parallel line. All right, my friends, so that wraps up our lesson on writing equations of parallel lines. All right, and I will see you in class next time.